In this video, we'll be looking at the addition rule for probability and its use in combining events. So if we consider the probability of A or B occurring, we're actually considering the probability of A union B. On a Venn diagram, this is shown as all of that shaded area. We can calculate the probability of A union B using the addition rule for probability, which is as follows. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection between A and B. Here we need to note that we subtract off the intersection just once, as it's counted twice overall when we add the probability of A and the probability of B. So on our diagram, if we look at the probability of A, that's all of that circle, and we've counted this already once. If we then go and count all of the probability of B, we count all of this a second time. So what we need to do is we need to subtract off one lot of that so that it's only counted once. Hence we have a subtract A intersecting B here. If the events A and B are mutually exclusive, then the addition rule for the probability simplifies to the probability of A union B is equal to the probability of A plus the probability of B. And this is because their intersection is the null set. There's no elements common to them. There's no overlap on our diagram. So the probability of A intersecting B is 0. So there's nothing to subtract off. Next, we'll consider the sample space where the probability of A is 0.4, the probability of B is 0.75, and the probability of A intersecting B is 0.25. You may remember these from a previous video that you've watched. And we're asked to find the probability of A or B occurring. So A or B occurring is the same as the probability of A union B, which we know is equal to the probability of A plus the probability of B, subtract off the probability of A intersecting B. So that's just the addition rule of probability. So next, all we have to do is put in the values. So the probability of A is 0.4, that was given to us up here. The probability of B is 0.75, that was also given to us up here. And then their intersection was 0.25, which was given to us as the third piece of information. We find that that is equal to 0.9. So the probability of A or B occurring is 0.9. Next, we'll consider the sample space, which contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, where the event A is defined as the list of 2, 4, 5, and 9, and the event B is the list of 1, 3, and 8. If each outcome is equally likely to occur, we want to determine the probability of A or B occurring. So for this, we can see that the elements in A and the elements of B have nothing in common, which means that A and B are mutually exclusive. And we found that out because A intersect B is equal to the null set. There's no elements in common. That means that when we're finding the probability of A or B occurring, which is A union B, we can use the simplified addition rule of probability, which says it's the probability of A plus the probability of B, with no need to subtract the intersection this time because the intersection has a probability of 0. So the probability of A is 4 events that satisfy A over a possible 10 events, plus the probability of B, which is 3 outcomes over a total of 10, meaning that the total probability of A union B is 7 over 10, or the decimal, which is just as exact, is 0.7. After this video, you should be able to understand how the addition rule for probability was developed or derived, use the addition rule for probability to combine events, that is to calculate the probability of A union B, and finally you should be able to use the simplified addition rule for probability when you're dealing with mutually exclusive events.